We're about to go live. Okay, hello everyone. Thank you for joining us today for another session at Coalesce. How's everyone doing? Middle of the day, end of the day, Wednesday. We're getting there. Lots of great DBT content. My name's Amos Buddy. I work at DBT Labs. I'm on the partnerships team working with services partnerships. I'm really excited to MC this workshop entitled DBT as a Serverless Service. We'll be joined by Kiran Shashadri, data architect at 4 Mile Analytics. I just want to remind folks, all chat conversations and Q&A are taking place in the Coalesce DBT as a Serverless Service channel of DBT Slack. This lets folks who are online participate in the conversation. The speaker and other folks from 4 Mile will be in the chat. Kieran will be speaking, but other folks will be in the chat, and then we'll be able to answer those questions there afterwards. If there's time during the session, we'll also take some questions as well. If you have already joined the Slack channel, just take a second to introduce yourself, please. And yeah, let's get started. Over to you.
Cool. You turn that one off. Yeah, okay, cool. All right, thank you. All right, everyone, thanks for attending our workshop, DBT as a Serverless Service. So before we get into it, I just wanted to introduce myself, talk a little bit about 4 Mile Analytics, and then we'll just jump into all the technical stuff. So a little bit of housekeeping first. So as you know, we have a Slack channel running here with the workshop resources. The resource files, which includes all the code we're going to review, is available at this tiny URL here, so you can snap a picture of that, screenshot, whatever you need. Every time a file is referenced, you can look out for that little file icon, and you'll know that what you're seeing is available in the zip file. I'd recommend you just kind of sit back and absorb the content here. We're going to be covering a lot very quickly. And then if you're interested in building this stuff at home, I would recommend doing that after the workshop. All right, cool. A little bit about me. This is from my MySpace profile back in high school, from this Battle of the Bands I played in. Someone in this room might have been there, actually. So, and then fast forward to 2022, picture of me still playing music with my band at Bottom of the Hill in San Francisco, where I'm from. Any San Francisco people here today? All right, awesome, cool. And then there's my LinkedIn profile, talking about what I do, data architect, right? So that's pretty much two things I love is data and music. So if you want to talk about making music or anything, just let me know. All right, so who's 4 Mile Analytics? 4 Mile is a group of almost 60 people distributed all over the world, mostly in North America and Australia. So we have 4 main operating groups: software engineering, data engineering, analytics, and design. We have a project management team that works with all 4 of those practice areas to ensure that we're delivering value to our clients on time. Our core values are up here: authenticity, kindness, humility, rigor, and empathy. So we strive to bring those values into our interactions with each other, with our clients, and the data community. So that's who we are. What do we do? So ultimately, 4 Mile builds data experiences. And what is a data experience? That might mean different things to different people. I think a data experience is a delightful interaction with data that allows someone to gain valuable insights into their business and take action. So a data experience doesn't necessarily need to be a shiny dashboard. It could be even a data pipeline or a script that is reusable for different purposes. At the foundation of a data experience, however, you do need a solid data integration and data warehouse strategy. We feel that DBT is the best framework for building robust data models and tapping into the full potential of the cloud data warehouse. Over the years, we've helped countless companies leverage DBT, and along the way, we've learned quite a bit about the challenges surrounding DBT adoption, specifically as they relate to the analytics engineer's experience. The challenges we've observed around DBT adoption, I've kind of encapsulated them into one sentence here. It's easy to get started with DBT core on my local machine, about how do I run this in a production environment. By show of hands, has anyone ever asked themselves this as they were learning DBT or heard that from any teammates or clients? Okay, I'm seeing quite a few people here. Okay, you're in the right place. So there's two buckets of challenges that we've defined. The first is procurement of SaaS. DBT Cloud is our go-to solution for hosting and scheduling DBT jobs due to the ease of use and setup and rich feature set that takes DBT Core to the next level. We've all seen that in the announcements this week. However, it's still difficult for large companies with different organizational stakeholders to procure DBT, and sometimes that process can take months, not allowing the analytics engineers to take advantage of DBT right away. It's not as easy as just entering your CTO's credit card and spinning up a couple of licenses, which some of us have probably done. All right, so some of the challenges here, right? Involves buy-in and approval from finance, IT, InfoSec. And the age-old question, are we buying another tool? Can't you just use something in our existing cloud service provider, like GCP? The second bucket of challenges is around open source orchestration. Who here is orchestrating DBT and Airflow? Let's get a... Okay, and who here has faced challenges around the deployment, setup, and orchestration there? So some of the barriers to entry around using Airflow are needing to know Python, needing to make decisions around who's going to host Airflow, how are you going to deploy Airflow, and figuring out how DBT releases are going to be coupled with Airflow deploys. That brings some additional complexity. How do you schedule a one-time ad hoc job without having to create a new DAG and a new DBT task using Python code? So we packaged these two sets of problems into a problem statement. Analytics engineers should be able to run DBT in a production environment without having to procure new SaaS, without having to couple DBT with the release cycle of another service, such as Airflow, without having to maintain servers, continuous deployment pipelines, and the code, besides the SQL. You still need to know how to write the SQL. This solution should have a quick point-and-click setup that allows anybody to go in and spin up the service without having to write code. We should require little involvement from our DevOps team. We should ensure interoperability with other data pipelines and other components of the data stack, which I'll get into. All right, so enter DBT as a serverless service. It's a mouthful, and it's really hard to say over and over again, but I'm going to have to do that for the next 30 minutes or so. So let's break down the semantics of this sentence here, DBT as a serverless service. What is a service? Does anyone want to give their definition of a service? Anyone want to give it a shot? Yep. Yep, something that can be provided or that you can provide, yep. Any definitions of a service in the context of software development and software architecture? Okay, no one has anything, so we're going to go to Wikipedia. Okay, so essentially, according to Wikipedia, a service in the context of software architecture is functionality or a set of functionalities that can be reused by different clients for different purposes. What does serverless mean? Anyone want to give that one a shot? It means there's no servers. There's no servers. Right. Or someone else's server. Right. Yeah. All right, let's go to Wikipedia again. So, serverless computing, right? It's a cloud computing execution model in which a cloud service provider allocates machine resources on demand, taking care of all of that infrastructure, and the client is only paying based on the actual amount of resources used. Okay, so now we know what a service is and we know what serverless means. Okay, so some of the best adventures in life start with just an internet Google search, right? So whether that's home improvement or planning a vacation or building a data pipeline, We can start at Google. So here we Googled Google Cloud Serverless Service. The first hit is Cloud Run. Sounds pretty interesting. I've heard about it a little bit, but I don't know exactly what it is. So what I'm reading here is Cloud Run allows me to build applications in our favorite language, abstract away the infrastructure management. So this is beginning to sound like it could be part of a serverless service solution to run dbt core in my cloud service provider. Okay, so I clicked on the other link that was there in the previous page, learned a little bit more about Cloud Run. So I can deploy a sample container that responds to incoming web requests. Perhaps I could containerize dbt core and my dbt project and deploy to Cloud Run and invoke a web request running my dbt commands. Let's come up with a plan to see if this is going to work. So it's a 4-part plan. I'm going to create a simple Flask API that runs dbt commands. I'm going to package the application in a Docker image. I'm going to deploy the Dockerized application to a serverless service in Google Cloud Run with continuous deployment via Cloud Build, which I'll get into. The final step is I'm going to expose this URL endpoint to authorized clients who can invoke dbt commands via a post request. Cool, here is kind of some whiteboarding architecture, right? And this is the architecture we're going to aspire to for this proof of concept of dbt as a serverless service. If we start all the way on the left, we have our analytics engineer committing SQL changes to a Git repo. They're doing their job, writing SQL, writing tests, and documentation. Can't forget that. They commit SQL changes to their Git repository, and they're merging PRs into a main branch. Making a commit into this main branch will trigger a cloud build job. That cloud build job will basically build a Docker image that is available to be invoked in Cloud Run, spun up as a live container, and to do whatever it needs to do. In this case, dbt commands. Okay, so first step in the plan, I need to create this Flask API first before I can do anything. So I can do that all on my local machine here. I just did it in 2 seconds. Here we have the app. Let's walk through what this app is doing, right? This is included in the course files, so you can go into it and judge my Python skills too. That's totally fine. So Flask is a Python-based web application framework. Basically, you can create your own API, which executes Python behind the scenes. So your API has resources which can get invoked using standard REST API protocol, or methods, if you will. The most common methods are get and post. So get is typically used to fetch or retrieve data that is requested. Post is used to send information to a server so that it can carry out some operations behind the scenes. The dbt command resource has a post method defined. And this post method will accept a list of dbt commands that should be run. So what this does is takes that list and first runs dbt deps. This simulates a lot of the logic that we enjoy on dbt cloud, where deps is run at the beginning of every job if we want it to. And then in sequential order, we run the remainder of the commands. So we can do dbt build, dbt test, or anything else that's a valid dbt command. Let's see. Okay, yeah, so a request will return a 200 response code if all the commands are executed successfully, and a 400 error code if the commands are either invalid or fail during execution due to something like bad SQL syntax or bad compilation. All right, cool. Step 1 of the plan is complete. We've created a simple Flask API that runs dbt commands using post requests. Step 2. Let's package the application into a Docker image. Who here uses Docker in their day-to-day job? Awesome. Cool. So let's do a quick crash course for those who are more unfamiliar. So Docker is a container orchestration software which allows you to define, run, and deploy your applications in any environment. So I want to be able to run my DBT service on my local machine and in Google Cloud Run. So let's see what that takes. We start on the left with a Docker file. This is essentially a blueprint for the application and includes specifications on the runtime environment that needs to be built in order for the service to run properly. The Docker file includes things like which operating system am I using, which command line interfaces are required, like DBT. What's the file structure like? Do I need some special directories? Which Python packages do I need to install? And which web server ports are exposed? Okay, so that's the Docker file. Moving along, we have Docker run. So this builds an image of this Docker file that can then be used to launch a live container instance of the image. The benefits of containerizing our DBT service using Docker is that we can deploy and run the service in any environment without any variance in application performance and functionality. So if it works on my computer, it'll work on your computer. It'll work somewhere in the cloud where it is deployed and where Docker run is available. Okay, so let's take a look at that first step, the Docker file. This is the blueprint for our service. We start by pulling a base image at line 1. In this case, we are pulling a basic Linux box with Python 3.10 installed. We create an application folder, it's called app, and we're going to copy our entire DBT project into the directory. We're then going to install Git. I learned that this is a requirement to run DBT core, or else you'll get warnings. So we just downloaded Git to suppress those warnings, but we likely won't need to use Git inside our container. Line number 9 is really important. This is where we're installing our Python requirements, which include DBT core. Let's double click into the Python requirements. So at the top, we're first installing DBT core 1.2. I should probably update that after this week. And then we're installing the Snowflake adapter. So if you're using BigQuery, you can use the BigQuery adapter. You can use it whatever you want. In this case, I'm using the Snowflake data warehouse. Below that, I'm installing our Flask requirements for basically running that application. So after running that pip install on line 9, we then define our port exposures. So Flask, by the Flask default, is to expose on port 5000. So we have that declared. Here, finally, this is the command on line 13 that is going to be run, that is going to be executed when we run a live instance of our container. So here we're using Gunicorn secure web server gateway interface to serve our Flask application. Okay, let's look at the anatomy of running Docker locally, of a Docker run command. We start off with a nested Docker build statement. This builds the Docker image from the blueprint Docker file and makes it available to be run in a live container. We then run the outer command, Docker run, with two important arguments here. -v stands for volume. So here, we're mounting our local DBT profile into the container on our local machine so that DBT core can establish connectivity with our Snowflake data warehouse. -p, this is our port exposure. So we are linking our local host's port 5000 to the container's port 5000 so that we can test out some post requests locally. Let's do that. In the resource files, we have a shell script with this Docker run command. So you can just run start local web server.sh, and it will launch your web server here. So port 500 on your local host is open and ready to take DBT commands. Easiest way to test this out is to run a curl statement. So we're posting to our local host port 5000 with a list of 1, right? So we have dbt debug just to see if we can connect. And that's the first step in checking if your DBT environment works, is running debug. As we can see, the command is successful, and the containerized DBT project has established connectivity with the Snowflake account and is running on our local machine. Okay, let's see how we're tracking on our plan. We got the Flask application. We've packaged it in a Docker image. Next step, we need to deploy the Dockerized application to Google Cloud Run with continuous deployment via Cloud Build. Okay, so this is where we navigate to the Google Cloud Console, to Cloud Run. And we're going to create a service here using an easy point-and-click user interface that Google Cloud provides. We are going to create a service with continuous deployment from a source repository using Cloud Build. In this case, we're using GitHub. So if we click on that Cloud Build, or that, what did it say here? So we click on Setup with Cloud Build. That will open up this modal here where we set up our CD. So in this case, our source repository is on GitHub. We can have it set up as a connected repository. This requires some authorization with your GitHub account. You can set that up by clicking Manage Connected Repositories and logging into GitHub. And then there, your repository will show up. This is your DBT project repository. Okay. Okay, awesome. So some things we want to make sure we do is we set our main branch to the branch that we are intending to trigger new builds to and new revisions. We're going to specify where our Docker file is located. In this case, it should be in the root of your DBT project and simply called Docker file. Okay, let's now configure the underlying infrastructure of our Cloud Run workers, which will execute DBT commands when invoked. So we're designating here that CPU is only going to be allocated during request processing. So we're not paying for any idle time during which DBT jobs don't need to run. We're setting a number of minimum instances to 0. This means that we may experience what's called a cold start when invoking our DBT service. This is generally okay because it doesn't take too long to build the image and to install DBT core. For the purposes of this MVP proof of concept demo, I'm allowing unauthenticated invocations and all traffic. You wouldn't want to do this. When you set this up, you will want to authorize only authorized IAM roles to make invocations here. But today, we're going to be a little bit scrappy just to get this out the door. Okay, so next, we configure the container settings, mainly the port. So we're specifying that requests should be sent to port 5000 here. This is analogous to our local setup process where we ran Docker with a port mapping from our local host to the container's port 5000. Next, we're going to mount our profiles.yaml to the container by referencing it as a secret in GCP Secrets Manager. So the local dev analog here is the -v argument. Similar to how we mounted our local profiles.yaml into the container, we're going to mount a Google managed secret into this Cloud Run container. Okay, we're all done with setup. That was super easy. It only took a few minutes. It was a point-and-click process with a delightful user interface. And the result here is this URL, which is effectively the endpoint for our DBT as a serverless service. Let's go back to our plan. Okay, so we deployed the Dockerized application to Google Cloud Run with continuous deployment via Cloud Build. The last step in the plan is to expose the URL to authorized clients who can invoke DBT commands via post requests. So when we were testing this out locally, we hit our local host port 5000, and that worked well. So let's use that same curl command, except let's hit our DBT service URL endpoint that was created by Cloud Run. So if everything was set up correctly, this should work. And When you invoke dbt debug, it will run deps by default, and then your dbt debug with a 200 response code. You can check the logs in the Google Cloud Run interface. As you can see, we have our expected dbt debug output with our connection stuff indicating that all checks passed. Awesome. So we finished the steps that we set out to do in our plan. So now what? We need to schedule this, right? So in our architecture diagram, we had scheduling by, or invocation by someone or something. That was kind of a question mark, right? So we want to ensure interoperability with the rest of our data pipelines and rest of the components of our data stack. So this architecture supports this concept of bring your own scheduler, right? dbt runs can be scheduled or triggered by anything that has a REST client. So some ideas here is you can set up a cron job schedule task that invokes a curl command. You can set up a basic Python task that is invoked by a Python-based orchestrator like Airflow, Prefect or Dagster or what have you, right? Here is some sample Python code that you can use to invoke this dbt as a serverless service. This is far more simple than having to nest entire dbt project inside another orchestration framework and tightly couple it with that framework's release cycle. So bring your own scheduler. That's one of the key advantages here. Okay, but everybody has that one friend who shows up without their own scheduler, right? And so they can, what they have to do is wake up and run dbt before everyone checks the reports, right? But they might not want to do that. So we need to help them build their own scheduler. So should we help them make a scheduler or no? Should we help them? No? Or who thinks we should help them? Okay, let's help them. So luckily we can use Cloud Scheduler. It's already in Google Cloud. Similar to Cloud Run, point and click setup to schedule cron tasks. Go back to Google Cloud. We navigate to Cloud Scheduler. We schedule a job. Here we can define the job schedule. So I'm going to name this job dbt run. And what it's going to do is invoke dbt run command on my Cloud Run dbt service. Frequency is going to be every day at midnight before everyone wakes up to check the dashboards. And then we're going to configure the execution here, right? So we are hitting an HTTP target. We have our Cloud Run service URL. We're defining that it's a post method. In our body, we have the list of dbt commands that we want to run. In this case, I want to run dbt run on this schedule. Okay, so we set that up. This is the main dashboard with all of our Cloud Scheduler jobs. That green check mark on the left indicates that this job is in a healthy state and its last run was successful. We have things like the last run. We can probably add, oh yeah, next run is right there. We can force an ad hoc job run if we need to as well and view the logs. Cool, let's go back to our architecture just to make sure we're tracking according to what we set out to build, right? So we were able to build a framework by which an analytics engineer commits to GitHub. And GitHub is continuously integrated with Cloud Build and builds a Docker image that's available to Cloud Run. Using this concept of bring your own scheduler, we can invoke Cloud Run by whatever means necessary, whether it's on a schedule or part of some other greater event-driven pipeline. Okay, so having a plan is great, but we need to compare our plan to the original problem statement. So let's do that. So analytics engineers shouldn't have to deal with any of this stuff, right? Procurement of SaaS. We were able to leverage our existing cloud service provider. So we did not have to buy anything new. Coupling dbt with the release cycle of another service such as Airflow. dbt lives by itself in its own repository, in its own continuous deployment pipeline. We don't have to maintain servers or CD pipelines or code besides the SQL. The solution involved a quick point-and-click setup and requires no ongoing maintenance at this point, other than maybe creating new job schedules or tweaking the schedule. There was no involvement necessary from our DevOps team. We were able to self-serve here. We've ensured interoperability with other components of our data stack through the bring your own scheduler idea. Okay, cool. So we took a look at the problem statement, but what's the long-term impact of this solution, right? The original problem was it's easy to get started with dbt core on my local machine, but how do I productionize my project? Our solution, right? We can now confidently say, my company runs dbt as a serverless service in Google Cloud Platform. Our dbt project is continuously deployed as a Cloud Run service and invoked on a daily schedule via Cloud Scheduler. That's awesome. And it's great that we learned all these new technical skills and everything, but people won't remember us for how good we were with Docker or Cloud Run or any of that stuff. People will remember us for the value that we created. So the real value add here is that we overcame technical and organizational hurdles to dbt adoption, and we moved our company towards a more analytics engineering best practices. Okay, so the bad news, though, is that people might forget about the value you added too. So, they need to remember us for something else. What else will they remember us by? How much money we didn't spend. So this is a big deal, right? So cloud cost management. Who here is in charge of managing like their cloud bill, AWS bill, and stuff like that? Or who here is accountable for that? Okay. So let's do kind of a cost of ownership analysis here of the architecture that we just built. Let's take the most expensive case scenario. Let's say we have one instance of this service running 24/7 with the smallest infrastructure settings available from Cloud Run. And let's do some napkin math based on the pricing that they've provided. Here we have the billable cost units of the architecture, right? Cloud Run costs have 3 components: CPU, memory, and requests. And then Cloud Scheduler, you pay per job. For most of these items here, we fall within the free tier, except for Cloud Run CPU. This is where we're paying, right? But again, this is a worst case scenario in which you have one service running 24/7. It's unlikely that if you are building this initial architecture that you will have the need to run dbt 24/7, but you can divide that number by however long you think you're going to be running it, right? And this is what you would pay per month. Okay, so this is what you can try at home if you want to explore dbt as a serverless service. So on your local machine, you can install Docker Desktop to run the container locally. You can add the project files into your dbt project repository. You can run the Docker service locally and try making some curl requests to your local host. Then when you're ready to deploy to GCP, make sure that you have IAM role permissions to administer the following services: Cloud Run, Cloud Scheduler, and Secrets Manager. You can probably set up a development environment or sandbox to do this. And then you can follow, we're going to share these slides in a PDF in the Slack channel, so you can follow these slides, follow the screenshots, and to schedule your dbt run service. Awesome. So I want to acknowledge there's lots of other people in the community that have discussed serverless architecture as well. There's a great channel on the dbt Slack, Deployment and Orchestration, where people are always talking about the cool things they're doing around this topic. So our goal is to continue that conversation and shed more light into dbt as a serverless service. So on the Slack channel, we're going to start a couple of threads here. You can look for the thread emoji, and you can use that and comment with any input you have on the following questions. We still have a long way to go, right? This is sort of an MVP state. So how can we implement CI and CD into this process? Can we make the service stateful and take advantage of things like the state method and dbt manifest? Can we use Cloud Run to serve up dbt docs internally as a static web page to our team? How is alerting handled? Is this the responsibility of our service or the client that's scheduling the service? And what is the best way to replicate this serverless architecture in AWS or Azure? Today, we only covered Google Cloud. So I'd love to hear what everyone has to say about these questions. So join us in the Slack channel, and feel free to post any content that you think is relevant. Otherwise, that's it for today. So I hope that you learned about a quick and easy way to get started with dbt as a serverless service, and you can take this back to your org. If you're a consultant, hopefully you can help some clients get started with dbt quickly. All right, thank you very much.